All right, in this video, I'm going to tell you guys about scientific notation, which is going to be absolutely crucial to get through this class with. And then one little slide, maybe two slides, about proportionality. And then there'll be one more slide or one more video after that. Oh my gosh, they just keep going. All right, so scientific notation, it has this general form of m times 10 to the n, where this number out front, m, it's going to be greater than or equal to 1, but it's always going to be less than 10. And this is just going to be a number. Might be positive, might be negative. All right, the thing is with scientific notation, it allows us to use really, really, really big numbers and really, really, really small numbers. A couple advantages are, well, you can tell the sig figs right away. So if you're looking down at these numbers here, 2.46 times 10 to the 4, 3 sig figs. It's just the numbers out front here. Every number that's here counts as a sig fig. So you ignore this part, but you just count your sig figs right off the front. Also, a lot of these numbers are going to be too big. You couldn't put it into your calculator if you tried to put it in standard notation for some of the numbers that we're going to be using. So how do I do this? How do I go from scientific to standard, standard to scientific? All right, so if I'm looking at a number, 2.46 times 10 to the 4, this exponent, that tells me how many decimal places I need to move the decimal place to put it into standard notation. All right, if it's a positive exponent, it's going to be a big number. If it's a negative exponent, that means it's going to be a small number, less than 1. So I'm going to start off with my 2.46, right? Click that. And I'm going to move this decimal. It's going to go over once, twice, right? Once, click, twice, 3 times, 4 times. Fill in the zeros there. All right, so I went 1, 2, 3, 4. All right, so 2.46 times 10 to the 4 is the same thing as 24,600. All right, so I moved it that way because that gave me the big number. If I went the other way, I'd have like 0.00, which is not where I'm going. This, you're never going to see this, but I just put it in there for giggles. 2.46 times 10 to the 0. 10 to the 0 equals 1, and 2.46 times 1 equals 2.46. So this would be a case where writing it in scientific notation, it is not going to be advantageous. It's going to be a pain. It's going to be kind of silly. All right, let's go to 2.46 times 10 to the minus 4. All right, this is going to be a small number, so I'm going to move the decimal in the direction that gives me a small number, so that's going to be to the left. So I'm going to cruise over, there's 3, 4 places, put the decimal point there. All right, so I have 0.000, so I have 3 zeros, so 0.000246. All right, so you can see this decimal place has been moved 4 places over. So negative exponent, it's a small number. Positive exponent, big number. All right, so we're going to use this a lot. Also, while I'm thinking of it, on your calculator, make sure that you are entering this correctly. You do not want to enter this in your calculator as 2.46 times and then 10. Like, you might see that 10 to the x key or like 10 and then raise it up a little caret thing. All right, don't do that because your calculator is going to think this is 2 different numbers. All right, there's a key on your calculator. It's like an EE key. If you have any questions, catch me in class or something, and I'll show you how to do it. But that way your calculator actually knows this is one single number. It's kind of like the times 10 to the key. All right, it's really easy. You just hit a 2.46 and then hit your EE key and then 4. And this is in there. All right, couple little things on proportionality. All right, we'll talk about proportionality a lot kind of over the course of the course. And so directly proportional, if they're directly proportional, what that means as one value increases, the other one will also increase. So if I double one, the other one doubles. So if I cut it in half, the other one cuts in half. So that's what is meant by directly proportional. So if I'm looking at the volume of a gas, right? As I increase the temperature, the volume goes up. They're directly proportional to each other. The other one would be inversely proportional. I actually hate this particular, I found this. I should actually go find a better one than this. I would rather have the pressure up here and the volume down here, but volume and pressure are inversely proportional. So what does that mean? That means like as you decrease the volume on a gas, right? For example, so I decrease the volume, the pressure is going to go up, right? So as one gets small, the other gets big, or vice versa. One gets big, one gets small. Cool. All right, so that's that. I think I'm gonna save. I have one little smudge left from this chapter. I'm going to put that into one final other video, and we'll call it good. All right, catch you on that one.